Okay, you heard that? So we're gonna start, recording is starting now. And so let's get started recording, and maybe I can, the problem is that I go to the, let's start at the start, the history of computing. And in this nice little, so I have to say thank you to Andrea and what's the other one? Abdul Latif for putting these notes together. I think it's kind of cool. Anyways, if you see there is a long history of computing. Before there were big electronic machines that we call computers, there were things called abacus, and that's going back to 1100 BC in Greece, and then picked up by the Chinese a couple thousand years later. Then there was a fellow by the name of Babbage, who made a mechanical computer in the 1830s and some Boolean logic. And then there was a electronic tabulator in 1880, which was used for a census. Then we see a bunch of computers that were like EDVAC and ENIAC, etc. after World War II. The transistor, which is shown there as a radio, but it was actually developed as part of the space program, because, you know, how do you get sort of any kind of calculations going on in something so that where weight is so important? You want to have as low a weight as possible. So transistor was a great breakthrough because that meant that you could replace vacuum tubes with transistors. Then we in the 1960s, they developed integrated circuits. And so we could have a chip with many, many transistors on it. And that led us to kind of where we are now. So there's some terms that we want to talk about. And I had a different presentation that I gave to the previous class. And maybe I'll give that to you too as well, or I'll share it with you, where I focused on the things that were in the textbook, because there is a textbook for this course. And if you look in the notes, well, I'll share you the video that I gave the other class, but there is a textbook, and I was able to find that textbook because I know this course is new. I'm not going to find the textbook in the bookstore, right? So I did a Google, and sure enough, there's a company that has that book in an online e-version, and you can join them, and it's like $8 a month, and you can quit at any time, and the first month's free. So I took the first month free. I mean, you guys could do the same if you wanted. So just Google the textbook. I'll leave you details of the textbook. I think it's actually in the course outline. If you look in the course outline, it says what the textbook is. But the textbook, the first couple of chapters in the textbook makes a big deal about what they call computational thinking, and also logic, computer logic, and just general logic. So let's talk about computation, which is obviously related to computational thinking. And it says there it's the act of computing. They used to have people that they called computers, and they basically were kind of like accounting people, you know, just doing mathematical stuff. So that's why the term also means calculating, determining something by mathematical or logical methods. So that's why we had people that were called computers. And computer science, it's part of engineering, as you would say. It's new, obviously. So it's part of engineering science, developed since the 1950s, where we look at all aspects of computing hardware and software. And so going to the hardware, a little bit of history, and I'm not going to go on all of this for hours and hours on this. I think to get the idea, you may have seen an abacus sometime. Abacus does make computing numbers more efficient. And so so you can multiply numbers quite quickly with this device. I'm not going to try and tell you how to do it because I've never used an abacus, to be honest. John Napier invented this idea of logarithms when I was a schoolboy in 1971. We had a little book that we used to take with us to our math class, and it was a book of logarithmic tables, which were developed by this fellow. And the logarithmic tables, you know, they were the sine of this, the cosine of this, the tan of this, yeah, the log of that, log in, and we would use that for a lot of our calculations. And all engineers would have one of those with us, and we had to have that logbook. And then we had a slide rule, and so you could do calculations a lot easier than longhand sort of mathematics. So the logarithms book made that little bit of mathematics a little bit more easily. Followed by the name of Pascal. He was an interesting guy. A lot of these really, really smart guys are smart in lots of different ways. And Pascal was one of those. He was a philosopher as well as a mathematician. And I guess you could say, and a developer of the computing devices. And so he came up with this device that was, when we say a machine, obviously it didn't have any electricity because nobody was using electricity properly until the 19th century. And this was well before that. But he did have a machine that would work with numbers. Leibniz. So this is the thing, right? We do get a bit of a, I'm from English speaking country. And so we have a Anglo-centric world history. And so the Germans are often left out of that for some reason. So this fellow Leibniz, he came up with a quite a fantastic device as well. But he wasn't French and he wasn't English, so he doesn't show up in the thing too often. Leibniz, I believe it was him, because the timing is about the same. But you may have heard of a fellow by the name of Isaac Newton. Isaac Newton is credited with the calculus, with developing the calculus. And I believe Leibniz actually developed the calculus at the same time. But as I said, in the English textbooks, we don't hear about Leibniz, we hear about Isaac Newton, who was pretty extraordinary anyways. But he didn't invent any computers. Just, how can you say just, right? There was a plague. I don't know if you guys ever heard of that. In the 1660s, there was a plague and went all across Europe. And the plague was kind of like COVID, except worse. People actually died. The Spanish flu was in the 1920s, but there was a plague in the 1660s, and millions of people died in Europe. And they closed down Oxford and Cambridge University so that the students couldn't go to university. And yeah, it's Black Plague, that kind of thing. And so Isaac Newton was a really smart guy. He was about your age, but a really, really smart guy. I mean, you couldn't go to university. So what did he do? He went and he sat in his house in the farm away from the university for 2 years, and he invented the calculus. You know, well, what are you going to do when you can't go to university, right? Well, you'll invent the calculus, I suppose. If you're Isaac Newton. Some of you guys will have to do calculus, right? That's a new course here. So thank Isaac Newton and Leibniz for that. Don't forget the Germans. They developed it sort of independent of each other.
This thing not have happened with these two scientists. There is other, like some say that someone stole Tesla's idea. It was Thomas Edison.
Yeah, Thomas Edison stole a lot of Tesla's ideas and made a lot of money out of it. Poor Tesla ended up with not very much money. I went on holiday to Belgrade a few years back, and you know, the airport is like a Tesla airport, right? And everywhere they've got this stuff about Tesla, you know. They're a little bit upset about Tesla. But well, they're not upset about him, but I mean, you know, they think that he was not properly credited. So here's another one. This guy, so computerized weaving. So this guy, JACQUARD, was able to use cards to make weaving a more faster thing. And they had those piano cards. I don't know if you've seen those. Well, they'd have drums with make the piano work. That was in the 19th century, but this was early 19th century, using punch cards as a sort of a mechanical programming. And yeah, and so Charles Babbage did something like that as well. Again, I'm not going to go into a great detail. Up until this point, Charles Babbage, all of the other ones that went before him, everything's mechanical. We're not using any electrical or electronic sort of switches. And so basically we're just using kind of like clockwork, because I guess you could say a clock does a bit of mathematical stuff, doesn't it? You know, and so that kind of thing, well, not my, I shouldn't point at my clock because it's just a computer. But what I mean is your mechanical clock can do mathematical stuff. I mean, it can tell time, which is mathematical, with the right gears and relationships between those gears. And that's kind of what Babbage's engine and those type of things were doing. All right, and so I hope you can see that. Doesn't it look like a kind of fancy clock? It kind of was. It was a clock that you can sort of work with. So, you know, I think that they're building upon the genius of like the Swiss clockmakers, right? So you got all these gears and, you know, this, and no doubt it's on the base 10. right? And so this one is going to crank over by 10 and this one by, you know, that type of thing. And you're able to do some calculations with it. Few famous ladies in computing. And one of the first was, here you see here, the daughter of Lord Byron, who was a poet, Ada Lovelace. And Ada Lovelace was able to make quite a contribution by writing program for the machine that had been developed to that point, Babbage's engine. And so the United States, as it got bigger, this came up a couple of times, but basically one of the biggest computations that they had to do is their census, what they do every 4 or 5 years. And so when they did the census in 1890, they developed a machine. And again, it's not electronic in any way, but it uses punch cards in order to calculate numbers for the census. And IBM sort of went with that idea. IBM bought the machine and then they developed these cards. Now, when I first started at university, I did do a computer course my first year at university, though my first degree was in chemistry. And chemistry people, we used computers. We used computers to, well, what I used them for in my chemistry degree was to calculate rates of reactions. But so we had to write a few computer programs and things like that. We actually did it on a PDP-11 terminal connected to a mini computer. But in the first math course that I did at university, we had to write a little Fortran program, and we had to use these cards. So there are two types of cards. One of them had punches in them. You'd have punched the card out. The ones that we had at our university used a pencil, and you just put in the number, you know. But that's how. So to write a very small program with, you know, 10 lines of code, you'd have 10 cards, a card for each line of code. That was kind of fun. Then here we see IBM made a device that used vacuum tubes. I think this one's got vacuum tubes. That's 1944. That's when we're getting into some real computing that we would recognize using electricity and not using electronics, but not using electronics that we would recognize today, but still using electronics. When I say not using electronics that we would use today, they use these big vacuum tubes. When I was a kid, our TV used to get real hot. It used to take a long time to warm up. You turn it on and then it'd take, you know, 5 minutes before you could watch it first. What you were waiting for is for all these vacuum tubes to warm up to the operating temperature. And if you looked in the back of a TV or any electronic device from the 1950s and 60s, you'd see these tubes, and also a big cathode ray tube. But we don't use those anymore, right? No cathode ray tube here because we've got much better devices using LCD, you know, this type of thing. So the cathode ray tubes, they use a lot of electricity. And so that was one problem with them. The other thing is they used to break. So, you know, you had somebody who's like their full-time job would be going around to the computer and replacing all the blown out vacuum tubes. And then the computers were huge. Now, each one of these vacuum tubes was a single sort of on-off gate or true-false gate, logic gate. What happened after that, and it's shown in the little corner down here, was after, well, between this and that is the transistor. But what we have here is the integrated circuit chip. The integrated circuit chip has got thousands, maybe millions, maybe billions nowadays of transistors on it. And each transistor is like one of these tubes. And so you get billions of them on this little thing here, which hardly uses any electricity. We run them with 5 volts, right? That's the electricity we're running in. And now Alan Turing, genius, somewhat of a misunderstood person. He was very unhappy. I think he didn't live to a great age, but he was quite smart, and he actually developed a computer that was able to crack the code that we call the Enigma code, which the Germans used to communicate between their submarines during the World War. And that was important for England because England, being a small nation and island, wasn't able to produce enough food or war material to keep in the war. And so much of their food and war material came from the United States and Canada. And that meant it had to come across the ocean. And so they put the boats out on the ocean, and the Germans would bring their submarines and sink them. And so when they knew where the Germans were, that made it a little bit easier. So that helped the British war effort quite a lot. So now we've got a few of these. I'm not going to go into a great deal on this, but fairly, World War II was very important in a lot of engineering technology and including in computing. So during that time, we got these universities bringing out these very large and powerful, at that time, computers. I mean, your pocket calculator and your mobile phone is a lot more powerful than these things were. But they used a lot of electricity, and you could write a few little programs with them. So there was that. They used a lot of power, 100 to 200 kilowatts of power, weighed 300 tons, 19,000 vacuum tubes, lots of relays. But then you could write a little program that said "Hello, Mom" or something like that. So we've come a long way since that. Then there was the first electronic computer there in 1947. Then we got a language by, who is this? This is Konrad Zuse of Germany. Again, the Germans don't feature much in British and American history for some reason. I don't know. He had his own language there called Plan Calcul. Very nice on the side here. Can you see this? I hope. So what you might be seeing on the side here is a model of our understanding of what's needed in a computer. And so a computer is going to have a CPU, central processing unit. It's going to have input device and output device. So input device is going to be things like card readers, keyboards. Now we talk to computers, don't we? But whatever we're using to take data into the computer, that's our input device. Output device is how the computer is presenting the information that it's processed. And so screens, printers, earphones, and then the central processing unit and a memory unit. So in the central processing unit that we call the CPU, that thing, so what, we have this thing called Moore's Law, which basically says every 18 months, we sort of double the computing power per dollar. And that's been kind of true since the 1960s. But we sort of come up to a, this doesn't happen in a straight line. It happens in sort of jumps. And one of the, it'll go and then plateau and then go and then plateau and then go. And so the plateau that it's hit at the moment is with processors. The big problem with processors is faster we make them go, the hotter they get. And so, what do we do to cool these things down so that they're actually usable? So that's where a lot of the, I think the engineering is working on at the moment to do something else so that we can get that processor to work and it's not going to melt the computer down and that we can actually fit it in a laptop, etc. And so the central processing unit is going to be that big chip. That's the expensive thing, your i7, whatever. That's the, and maybe they've got 3 or 4 of these CPUs together in this big chip. But it has a control unit and an arithmetic logic unit, as you might imagine. The arithmetic logic unit, that does the calculations. The control unit says which calculation to do next. And the memory unit stores data to be used in those calculations. And all of that can be on a CPU. Plus, there's a lot of other stuff in your computer for other storage, etc. And actually, there's lots of processing units because you'll have a special processing unit just for graphics. And another special processing unit just for communications. Okay, so von Neumann, this gentleman, he came up with this abstract diagram, this idea of how we represent a computer. That's von Neumann's model of a computer. So von Neumann proposed some other things, that a program be stored in binary code and that there be some memory unit. And you can see in von Neumann's architecture there that he has a memory unit as part of the computer. So we don't have to just put things in cards and take printouts at the computer can actually store some data in the computer as it goes. That made it a whole lot more powerful, So thank you, von Neumann, for that. Here's some more computers. And I'm not going to go into those in a lot of detail, just to say that those early computers, basically, the saying was that people used to program their computer with a soldering iron. In other words, they'd make connections between the various components. Then they got to very basic sort of what we call assembler language, sort of things where we had things like here, add R1, R2, R3, which is a very simple language of programming on the early computer, which means find the contents of R2 and R3, put them together and store them in R1. So you can see those languages were somewhat, we'd say, arcane, or they're not easy to read. The programming languages that we got now are a lot easier to work with. But at the level where the computer is actually working in the operating system, it's kind of like that. It's kind of like that. In the early 1990s, I was living in Melbourne, and one of my friends there, he worked for an airplane company, airline, and not an airplane company, airline, and he used to write in assembler language, which was kind of like this. And so we have lots of other languages. So why are they writing in a language like that? Because he could have very small programs that would run very fast. And so if you're with an airline, you want programs that run very fast. So how can we get fast programs running? Well, there's two ways. We can make really, really efficient code, which means we write in the lowest level language possible, or we can just have really, really fast computers, or we can do both. And nowadays, we've got such very, very fast computers that we can't afford to run our programs with, we don't have to run assembler language. Admiral Grace, so another famous lady here. Grace came up with this, she invented this language called COBOL. What is COVID? I got COVID on the brain. COBOL. Actually, it's one of the first programming languages that I learned. I learned that at university, COBOL. There's probably still some programs around using COBOL. So COBOL was used a lot as a business programming language. So your banks and governments, etc., most of their programming would have been done in COBOL through the 1950s, 60s, 70s, 80s. And it's kind of going out now because what we've done is we sort of moved to things to the cloud. And if we're going to go on the cloud, then we're going to use, your JavaScript and your Python and your Java, etc. But COBOL was a big deal in the 60s, 70s, and 80s. Another one was, okay, what do we got here? The designer of the integrated circuit and our RAM chips, our various RAM chips. Okay, so yeah, he founded Intel. Oh, whatever. Are you familiar with these terms? Kilo, mega, giga, tera, peta? Okay, so we use those terms for things of data. You can go down to Carrefour today and buy yourself a external hard drive for your laptop, which will be in terabytes. You probably got a terabyte laptop drive in your laptop, right? And maybe it's even an SSD, a solid state drive. Solid state drives, how awesome are they? Because they don't have any moving parts. But they do have a problem with sort of the data will fade because you're writing on the same point over and over. Yeah. Anyways, petabyte. Wow, that's a lot of data. But we need that because we are running out of time. It says we need that kind of data storage because of the stuff we're doing. Right, the stuff we're doing, right? I mean, you've got cameras all around cities that are taking images of people's faces, and then identifying them and sending them to government computers. No, that's a conspiracy theory, right? No, I'm not saying that's happening here in Qatar, but that is happening in some places. I believe that's what's happening in China, and it's happening in some places in Australia. So when you walk down the street, they take I mean, how much calculation is going on there? A lot. And so that's a lot of data. I mean, it's happening on my mobile phone. I pick up my mobile phone, it says, yeah, your face recognition, you're allowed to use this phone, right? So, I mean, that takes a lot of computing power. So I guess what I'm saying is the appetite for computing power is never ending, so you might have heard of these things like the Internet of Things, right? So imagine that every little device and component around has an IP address and is able to communicate to a network. So you when you go into a store and find a piece of clothing, right, you don't even have to go through the checkout. this could happen, right? Because as you walk out, there's a scanner there that just recognizes that device, and that goes straight to your credit card. Boom. Another conspiracy theory, right? No, actually, it's just a way of increasing the efficiency of shopping.
Real that Canada used to track people CCTV cameras or AI cameras. That shows the social security.
I believe it's true in one state in Australia and in China. You know, if you go outside, you know, there's cameras everywhere, and they used that during the COVID lockdowns. So you couldn't walk outside, right? Because, oh, you're not supposed to be out. You know, this kind of thing. Send the police with clubs to beat you up. That would never happen in Qatar, right? Inshallah. Mark, stop doing the conspiracy theories. Yes, Amazon store, which is cashierless. You can just walk out. Yes. So Gordon Moore's law, I already talked about that. The engineering, all the time, is just getting cheaper and more. How wonderful is that? Well, I don't know. You know, technology. Yeah, for us, it's wonderful because we're part of it, we hope. The graphical user interface started off kind of kludgy. Macintosh operating system, they're talking about early 1980s, I believe. And the OS 2, which is IBM's answer to that, which wasn't too bad. And then Microsoft, who stole it from the other two. Yeah, there's a lot of really nice people with IT. I don't know, Steve Jobs, you wouldn't want to be in the room with him, or any of these guys, to be honest. But they're really smart. And so, yeah, Steve Wozniak and Bill Gates, they did Microsoft, and IBM was really, really worried about sort of going out of business because they were a mainframe company, then they went to a mini computer company, and then along came these personal computers from Apple and Tandy and these other little ones, you know. But IBM, they made personal computers, right? And they actually contracted Microsoft to give them an operating system. So so Microsoft found this operating system called CP/M. It just relabeled it. Oh, we're inventors of a new operating system. Yeah, well, sort of. Yeah. Stanford Research Institute. Oh, you got Dinglewood. He's doing oh well, I don't know, the mouse. So the mouse is a pretty good idea. You can kind of see it hidden under there. And of course, I got my wireless mouse here. What would we do with that mice? And Ethernet, that's our cables. I'm not using Ethernet here because I'm Wi-Fi connected. Sorry, but we still use Ethernet. Not everything is Wi-Fi. Why are we using Ethernet? Because it's fast. And, you know, we're connecting it to a fiber backbone. And so Ethernet is a standard for cabling, which allows us to have local area networks. And that was, as it says here, was invented by Xerox. Xerox should be a big, strong computer company. So how did those other guys get ahead of it, right? They had a lot of they were ahead of them before. Yeah.
It's the same firm that HP wanted to buy.
Sorry?
It's the same firm that HP wanted to buy years back.
Xerox?
Yeah.
Probably. Yeah, probably.
They wanted to buy the printing.
Yeah. Xerox came out with photocopiers, and then but they had some pretty good ideas in computing as well. So the internet, so what is this, 1960s? Yeah, the 1960s. Stanford University, which is in San Francisco, and UCLA, which is in Los Angeles. So not too far apart, like 250 miles, but they wanted to communicate with each other, so they came up with a little network. And then they started pushing that network out to other places throughout the United States, other universities. And then the people who have the real money, which is, of course, the Department of Defense, the military, they thought that would be a good idea. So the Department of Defense there, DOD, ARPANET, they picked up the idea and they started using the network. That network, then the protocols from that network became useful and became commercialized, I guess you could say, in the late 1980s. And we got the internet. And mentioned at the start of the lecture, Tim Berners-Lee was the inventor of the World Wide Web, apparently. And he came out with, Mosaic came out after him. But Mosaic was a browser that we could use to render hypertext onto a screen. Google, yeah, that's all she wrote, right? Google, worth trillions of dollars. And yeah, what were they doing? Their search algorithms, right? I got 3 minutes left. Bill Gates. Well, yes. What can we say about Bill Gates? Very smart guy. These two guys apparently came up with Google, which they called Backrub. Started out at the university, and then they pushed it out to the whole world. And now, I mean, they're so big that they're significant in social issues, etc. Right? I mean, you know, they can tell you what news to read. You know, that's fake news. You know, can't look at that. You're banned. Wow, they got a huge amount of power. So and a huge amount of money. And so, like Amazon. Somebody mentioned Amazon. Would you call that an IT company? I think so. Right? Everything's online. And so what they go into space and they talk about going to Mars and stuff like that. Jeez, what kind of money is that, right? I remember Windows 3.1 when it first came out. Yeah, that was fun. So Windows 3.1 kind of looks, you know, like our screens now, except a lot kludgier. And there we go. Wikipedia 2001. Who hasn't used Wikipedia? Everybody uses it, right? But I like Wikipedia. I mean, you know, you have to be a bit careful with it. You know what I mean? It's not like peer reviewed. It is in a way. It's like the world peer reviewed, right? So you can go into Wikipedia and enter it, edit it, and then somebody else will come and edit it and change what you did. It's okay, I suppose. Linux is the best. Yeah, okay. Somebody likes Linux. Maybe the reason why they like Linux is because it's open source and you don't have to pay Bill Gates for it. I don't know if that's the reason why I use it. Also, probably because it's more efficient and works nicely with it's optimized for networking. So yeah, so Linux, people like that. Yeah. YouTube was founded. Who doesn't use YouTube? I'm going to be using YouTube in about 5 minutes to put this onto YouTube, and then you can use it. Yeah. And Nintendo, why? Okay, so there we go. Just some history there. I'm not going to go through all that. So we've come to the end of this. Thank goodness. We got 1 minute left. Have we got enough time to do this? Guess who? Guess who what? Guess who is this? Steve Jobs. The late Steve Jobs. He died like, I don't know, 10 years ago or something, cancer, right? He wanted to treat himself.
Yeah.
That worked out not so well. I should laugh, yeah. I'm really sorry about Steve Jobs. This guy is Babbage. Analytical engine. Sorry, this guy. Turing. You can tell by the clothes, right? 1940s stuff.